Hi, everybody. Welcome back to the Rule Your Pool podcast. This is episode 108. And in this episode, I'm going to talk about a green pool. I guess I should say the Rule Your Pond podcast. Because right after I record this episode, I'm going to go into the backyard now that I have what I've requested. I've got all my Hasa chlorine and acid has been delivered finally. It had to be shipped from across the country. Long story. It's not available on the East Coast yet. But I have it now. Had to get some parts for the filter and the multi-port valve so that we can get circulation going. And right after recording this, we're going to go out there, get on Facebook Live, and we're going to bomb this pool with the Orenda Purge, the green pool cleanup. And if you're familiar with our green pool cleanup, we talk about it in Orenda Academy, and it has been on our website for many years until recently. Don't worry, it will be back up there at some point. It's just going through review for verbiage. The procedure has not changed. I'm going to demonstrate it on Facebook Live, and of course this is going to take some time to edit, so maybe that happened yesterday. Kind of odd speaking about yesterday when it hasn't quite happened yet, but by the time you hear this, it was Tuesday night, May 9th, 2023. We're going to have fun with it. I've cleaned up several green pools in the past, and we're going to trust in the system. Let it do what it's going to do. And I want to kind of expand it in this abbreviated episode about breaking the water. We talk about this concept of breaking the water back into condition. And when I say breaking, think about like breaking a horse and domesticating it. It's kind of like that, at least in my head. What we're doing is we're trying to break the water's current conditions so that we can recondition it to behave the way that we want it to, so that it's predictable, that it's clean. This can involve quite a bit of chemistry. It may involve cleaning filters. It may involve a whole bunch of other stuff. But generally, we reset both sides of water chemistry. We reset the water quality and water balance with the LSI. So let's get into it. Episode 108, Breaking Bad Water. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. When I talk about bad water, what does that mean? I've got some episodes here in my show notes that I'm the only one who ever reads. Green pools, I talk about in episode 25 on how to diagnose it with the white bucket test, and episode 26 on how to treat it for various reasons the pool could be green. How about cloudy, murky water? High chlorine demand. We talk about not being able to hold chlorine for a week in episodes 22 and 76. High combined chlorine levels, maybe, episodes 32 and 33. Discolored water, nasty water during spring openings. You pull back the cover and it's just gross. Episodes 56 and 60. Greasy water, where you can see the oils on the surface and maybe some scum lines. We talk about that in episode 63 with the purge. And 66 with how CV600 works. Breaking is a term that we use to do a hard reset. Change the water. Fundamentally, get variables out of the equation. Take things out of the water. I don't want a chemical cocktail in my backyard. I don't want to swim in that. I don't think you want to swim in that. Kids shouldn't swim in that. If we are just throwing chlorine at a problem, that's not an effective way of getting rid of everything. Now, chlorine is an excellent disinfectant. It is an excellent algicide. It's the best algicide. It's awesome at killing things. But it wasn't really made to handle everything else. There are a lot of other contaminants. And as we speak about often on this podcast, the vast majority of chlorine is used up on non-living things. It's called the oxidant demand. 3 categories of oxidants: metals, nitrogen compounds, and non-living organics. Of those, the vast majority is non-living organics. So we supplement chlorine. We want to support it. We want to take things out of the equation that are not part of the sanitizer demand. To properly break bad water, you need to reset both water quality and water balance. With regard to water quality, let's remember the holy trinity of pool care, or as we say in Orenda Academy, the Pooly Trinity: circulation, filtration, and chemistry. You need all 3. In my pond in the backyard currently, I have not been able to clean the pool yet because the filter is not operational. The pump is, thankfully. We got that working. But we had to replace a time clock to get that, and it had sat stagnant for 5 or 6 weeks before we even got that fixed. But now we have to get the filter operational. We've got to get a gasket fixed to the multi-port valve so that we're not spraying water as we circulate. And then we will be able to chemically treat it. And that's what we've been waiting on. We would not be able to clean this green pool without all three: circulation, filtration, and chemistry. We also need to diagnose why the water is green. Well, I already did that. I probably should do it again on Facebook Live, but it's definitely algae. Okay, took a white bucket, grabbed a bunch of it, put liquid chlorine in, cleared right up. So we're ready to shock the pool. Now, if you have bad water, find out what it is. Sometimes you can just look at water and say, okay, this is not right. Check your filter. Check your circulation. Make sure that your filter is actually cleaning things. You could have a channeling problem. You could have a broken grid. You could have a cartridge that's torn or something like that. I don't know. There's too many variables in it, but generally make sure circulation and filtration are operating correctly, and then we can address chemistry. In my opinion, maybe I'm biased because, at Orenda we're a chemistry company. Chemistry is the easy part. If you don't have the fundamentals in place with circulation and filtration, you're at a huge disadvantage. You're not going to be able to fully clean up that pool, especially not the pond in my backyard. If I'm going to try to rule my pond and convert it into a pool, I have to have all three. So if you've got a green pool full of algae, I have a question for you. What have you been doing in the past? If you're a pool pro, think about your procedure. If you've been in this industry for at least a year, you've almost certainly seen at least one green pool, probably many. What have you done in the past to fix that? Put an example in your mind. You got to the pool, it's green, can't see the bottom, full of algae. Let's just say it's like obviously algae. There's stuff growing in it. You could see it. What did you do? What was the first thing you did? Did you test the water? What did you test for? Did you believe the results if you tested? When you tested it, where was the pH? Was it measurable? All right, so assuming you know what you're doing, you've done this multiple times, you keep seeing the same stuff, you walk into the backyard, you know what to do. What do you do then? What's step one? See, a lot of people that we talk to go in with the kill it all, let God sort it out mindset. Just nuke it. Let's throw in everything, including the kitchen sink, at this problem. Let's hit it with a huge amount of chlorine and algaecides just for good measure. If you do that, where's the chlorine the next day? And is the pool clear? It might be. I mean, if it never did that, obviously people wouldn't keep doing it. But a lot of times customers call and they say, it didn't really clear it. The water's just kind of gray the next day and chlorine is 0. Well, how did that happen? If you go back to episode 26, Jared and I talk about it, and that was actually recorded in June of 2021. That was 2 years ago. We've learned a lot since then, but in general, that episode is still relevant today. The reason that just throwing chlorine and stuff at the problem doesn't solve it long term is because you're not addressing the root cause of the problem. You're only killing the algae, and you're killing it really hard. And killing it harder with extra things like algaecides. But why are you using algaecides? Chlorine is the best algaecide by far. We at Orenda do not promote the use of algaecides because they leave behind long-term byproducts. If you remember, our philosophy has 3 tenets: proactive pool care, no chemical conflicts, and no long-term byproducts left behind. Algaecides are none of those 3. Algaecides are reactive. I suppose there are some that could be proactive. At least the intention could be proactive. But realistically, it's a reactive product. All algaecides are. They're there to kill something immediately. And they do, by the way. They do work. They kill algae. I'm not saying these products don't work. But they're not necessarily proactive. They will conflict with chlorine eventually because their long-term byproducts will conflict with chlorine. I mean, pick your poison. Sodium bromide, that's going to conflict with chlorine because bromine conflicts with chlorine. Eventually, if you get enough bromine, your pool will become a bromine pool. And in an outdoor pool with direct sunlight, bromine creates bromates. You don't want those either. How about ammonium chloride or dimethyl ammonium chloride? Well, that's ammonia. Combined chlorine, need some breakpoint chlorination. How about ammonium sulfate? Same thing. Plus sulfates, which can accumulate over time and maybe lead to calcium sulfate, which we talked about in episode 104. Polyquat. Well, polyquats, they conflict with our enzymes. You'll get a bubble bath for a little bit. And quat is short for quaternary ammonia. The point is, these all leave behind byproducts that will eventually conflict with chlorine. We don't want that. But I digress. This isn't about algaecides. This is about breaking the water for the long term and resetting it so that it gets back in line. If you throw in a whole bunch of chlorine and algaecides and you come back the next day and the pool is not clear and the chlorine level is at zero or close to it, then clearly something went wrong. I mean, you threw in enough chlorine to easily kill everything in that pool. But why didn't it work? Well, that's because you were killing multiple generations of algae. You didn't get rid of the root cause of it. And so it was able to continue to regenerate over and over and over again. I've seen in sources before that in the right conditions, certain types of algae can reproduce every 3 to 6 hours if they have everything they need. So let's take other things out of the water. We'll just say it like that. We don't want to just kill algae with chlorine. Chlorine is the sanitizer we're using. That's what kills algae. No Orenda product does that. Want to be very clear about that. You have to take care of it with chlorine. And we like non-stabilized chlorine. You could do this with liquid chlorine or cal hypo. What you don't want to do is throw in a ton of stabilized chlorine, whether that's granular trichlor or dichlor. Sure, it can kill algae, but it's also going to spike your CYA levels, and that's what we want to avoid. So we say non-stabilized chlorine. That's what's going to kill the algae. An EPA-registered sanitizer. Everything else is non-living. That's where Orenda products can help. We're just going to take other things out of the water. We're going to take non-living organics out. We're going to break those down because I promise you the pond in my backyard right now is loaded with organic material. You can see it, and unfortunately the neighbors can smell it. It's not good. It's not good. But we're going to get that out. PR10,000 is going to remove phosphates. We're going to get those out of the equation. We're going to simplify this water so that chlorine can just focus on cleaning the water. That's how we're breaking it. So with a green pool like this, we're going to shock with non-stabilized chlorine after lowering the pH. We are going to remove variables, meaning we're going to purge with PR10,000. At least 16 ounces normally if it was not a green pool, like if you're just trying to break it. The Orenda bomb is 16 to 32 ounces, depending on the severity of your issue, but I'm just going to use 32 ounces, 1 quart per 10,000 gallons for the green pool, and 1 quart per 10,000 gallons of CV600 or CV700 enzymes. Then we're going to let this stuff fall out. We're going to vacuum the waste, and we're going to clean the filters afterwards. Now, the procedure for the green pool cleanup is to remove as much material off the bottom as you can with a net. Then, once you think you've got everything, because you can't really see it, you're going to brush. Get it all off the walls, stir it up. Then you're going to lower the pH with diluted acid, because the pH is very high, because algae consumes CO2, and it pulls CO2 out of solution, which raises the pH. Then, we're going to shock. Liquid chlorine. We're going to raise those chlorine levels, and we're going to immediately follow that up with 1 quart per 10,000 gallons of PR10,000 and 1 quart per 10,000 gallons of enzymes a few minutes later. Now, you could wait and do enzymes later than that. You could do it the next day. I'm going to do it all together. That's what I'm about to do because I want all of it to work together, and we're just going to time-lapse it on a GoPro and film the whole thing. That's the goal anyway. Then you either circulate and you try to filter it out, which I'm not going to be able to do because I've got a DE filter and it would jam up immediately. So I'm going to shut off circulation. I'm going to let gravity drop this stuff out. The enzymes will float the oils to the top. Everything else will flock to the bottom. And tomorrow we vacuum to waste. Then we clean the filters and we're off and running. Now, in terms of water balance, remember we're talking about 2 disciplines. I know I went off on a tangent there, but resetting water quality is getting variables out of the water so that you can clean it up and regain control of sanitization, disinfection, clarity, all that sort of stuff. Water balance is actually just about establishing LSI balance. It's actually the easy part. This means testing and knowing what your total alkalinity, your calcium, water temperature, TDS, etc. Figure out what the LSI is and figure out what you need to do to balance it. 9 times out of 10, it's going to be adjusting your total alkalinity and calcium hardness levels. Most pools with bad water, I'm using air quotes, bad water that we're trying to break, don't have enough calcium and have too much alkalinity. Now, it's not every pool, but most pools tend to have those two things. Too much alkalinity, not enough calcium. That should tell you something. That's not a coincidence. If your pH keeps rising too high because you have too much carbonate alkalinity in your pool, your pH ceiling is higher, pH gets up there, LSI gets out of balance, people overcorrect with acid, it's this whole thing. So getting it in line is a matter of balancing the LSI. And the one factor that I want to make sure I bring up applies to both water quality and water balance, and that is cyanuric acid. If you are overstabilized, the best thing you can do is get that level down. That is going to impact both water quality and water balance. Overstabilized pools are a lot harder to sanitize because it slows chlorine down. We like 50 parts per million or less. Yes, you can go higher, but you have to have a proportional increase in chlorine to maintain the free chlorine to cyanuric acid ratio. It's just a lot easier, math-wise, to stay 50 or less. So if you are over 50 and you want to rule your pool, consider dilution or some other mechanism to get CYA down, like reverse osmosis filtration. That might be a good fit for you. Of course, if you have a green pool with really high CYA, which happens a lot, you need to clean up the green first because you don't want to jam up that RO filter. Then bring the RO filter in, take out a portion of your water, remove the CYA, do what you need to do. We like to say the Orenda purge is a hard reset, but our chemicals are only a hard reset for water quality. The reset for LSI balance, in most cases, is some diluted acid to reduce your total alkalinity and some calcium chloride to raise your calcium hardness. Generally. I mean, yeah, you might have to dilute water to get your TDS down and your CYA down, but the point is focus on getting the water back to the parameters that you want so that you can rule your pool and it doesn't turn into a pond. I'm sorry for making this a short episode. I'm running out of sunlight and my pool guy is arriving here and I need to clean up this pool. I hope you got something out of this episode. You can go back and listen to the previous episodes and learn more about that. But if you have questions, just hit me up, podcast@orendatech.com. I'm Eric Knight with Orenda. This has been episode 108 of the Rule Your Pool podcast. Take care, everyone.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.